Hello, classroom family. We are in section 11.2. We've got a chunk of things to do for homework, 1 through 9, 12 to 14, 16 to 18, and number 20. Let's jump in and take a look and see. This should all match what we've talked about in this section already. Which of the following are convex and which are concave? Good definition question, right? We've got to be able to identify those visually. Next up, so this is where I want to be really clear. I'm going to give you a list of terms and then give you 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the shapes, and they're spread a little bit at the bottom and some next to it. So I'm going to ask you to find me an isosceles triangle. There may be more than one that matches. Okay. So if it says a rhombus, make sure, does it meet the definition of a rhombus? If it does, mark it. Okay. So there may be more than one. I just want to make that very, very clear. Okay, so 1 through 9. So let's see, number 3, what is the maximum number of intersection points between two triangles where no sides are on the same line? So again, draw yourself some triangles. This is a good one to practice with. Draw a triangle and then draw another triangle. Now they can't overlap on a side because then we'd have to say infinity. But for example, if you draw a triangle like this, right? And I draw another triangle, right? Like this, like ha ha ha, then these two triangles have two intersection points. Okay. Could they have more intersection points? How many intersection points maximum between two triangles? All right. All right. Next up, a pentagon has two diagonals that intersect at a given vertex. Your turn now. So again, that pentagon, if we think about kind of that shape that I had drawn earlier, just a pentagon, doesn't have to be a regular pentagon, a pentagon. It has two diagonals that intersect at a vertex. So if you think about this vertex, think about it. There's one that comes out here, there's one that comes down there. Okay? And if you draw all the other ones in, then there's one that comes here and there's one that goes there, right? Okay. And then so the last one would have something coming over here. But if you look, every vertex has two of these that come in and touch it. All right. So determine how many diagonals intersect at a given vertex. Now we're going to do a hexagon, 6-sided. Then we're going to do a decagon, 10-sided, 20gon, and the n-gon. Yes, you knew it was coming. I want you to generalize. Okay. So that's what I'm looking for in that one. Let's see here. Let's move on. So I was up to question 4. Describe the shaded region as completely as possible. So what kind of things would be at the intersection of rectangles and rhombuses? Okay, looking at the terminology. Question 6 is a great one. Yeah. Draw me this shape if it is possible. Can you draw me a scalene equiangular triangle? Can you draw me an equilateral equiangular triangle? How about a right isosceles triangle? What can you draw and what can you not? Then identify acute, obtuse, right, or equiangular. And there may be more than one term. Keep that in mind. Nothing wrong with using more than one term. Are all equilateral triangles isosceles? Whew, go back to the definition. What does it mean to be isosceles, right? And remember, our book may be different than what you learned in a potentially another class. It's not to say that they're wrong. They just may have a more limiting definition. Okay, let's check next. Number 9, I think was my next one. Determine how many diagonals each of the following polygons have. Ooh, now it's total diagonals. So we started that. If you watched the video for the unit, I said, well, a triangle has 0 diagonals, right? A quadrilateral has 2 diagonals. A pentagon, we already saw, had 5 diagonals. I don't know. Maybe there's a connection. Hint, hint, huge connection, right? So when they say go to a hexagon, then to an 11gon, you might be starting to say from the hexagon, can I generalize? If you can generalize, then later, if they give you 11gon and 18gon, you just plug in the number, right? Whatever you can come up with. So maybe, and my hint to you is, maybe finding the n-gon is better. Once you find the hexagon and you can start to see a pattern, maybe find the n-gon and then apply it here instead of trying to actually go through and count all of those. It's a pain. It's a total pain. Okay. I think I said skip 10. Yeah, I did. Skip 10, skip 11 again. The only reason, I'll just tell you why I skipped those. If you look at this, there's kind of an implication that's made here that there would, there's usually kind of it could be some kind of symmetry. And then it gets down to like digging in. Is the loop on the B on top the same size as the loop on the B on the bottom? Because if not, there won't be any symmetry. And I feel like that takes away from kind of what we're trying to do necessarily. So not my favorite type of question. Up here, these are quilt patterns. If you've ever seen sometimes family members make quilts, there's different patterns that can be used, and a lot of times they use symmetry. So your goal is to identify the types of symmetry: line symmetry, turn symmetry, and does it have point symmetry? Remember, that would be a 180-degree rotation. So how many lines of symmetry exist? Again, give you a group of shapes, and you have to find all the lines of symmetry that exist. I think I said 12 through 14. There we go. So now this one's kind of fun, but you have to be kind of artistic and honestly, just do your best. That's all I'm going to say, right? So if you think about this, I got to choose a thinner pencil as well. It says these have line symmetry about the line. So then if it has line symmetry, remember, it should be able to reflect against this. So you are trying to draw that reflection, right? Because this piece here has to reflect to that piece there. And so as you draw it, that's what you're trying to sketch out. What does the shape look like if I know it has line symmetry? Okay, cool. Let's move on. I said 12 through 14, 16 through 18. So here's 16. Okay, so now this one is about turn symmetry. Here's 16. 17 is complete the figure. So they've started a figure, but the figure has point symmetry. Okay, so here's the point O, here's the shape. Point symmetry is that 180-degree turn symmetry. Now, if you need to visualize it at first, get a piece of paper that's as thin as you can find. Almost see-through paper is ideal, right? What else could you use? If you have wax paper in your kitchen or maybe parchment paper, you might be able to do it with this. And then kind of cut a piece of it out and lay it over the book or lay it over your piece of paper and then turn, put your pencil at point O, push, and then let the shape turn around so you can actually see the turn symmetry. And then that can help you kind of see, oh, I see what I'm doing there. Okay. There we go. What was it? 16 through 18. Okay, so 16, 17, and 18. Give the most general name for quadrilaterals having these symmetries. Now remember, these are only quadrilaterals, 4 sides. So 2 lines of symmetry through each pair of opposite vertices. Okay, 2 lines of symmetry. What kind of a shape has that? Is it a rectangle, a parallelogram, a trapezoid? What is the most general name you can find that makes that happen? Okay. And I think I did assign number 20. So this is in the tattoo and symbols. I mean, honestly, these definitely look like tattoos. So what kind of symmetries do you see in these kind of symbols? Do you have turn symmetry? Do you have line symmetry? Maybe point symmetry. Okay, what is possible? What do you notice in these? And that wraps up the homework on 11.2. So for some of you, again, you might even have your own tattoos and be like, hey, what can I rotate? Do I have any symmetries on mine? Again, to be perfectly honest, that's where you need a good tattoo artist, because if you find someone who's kind of freehanding symmetry, it may not look symmetric, and then you have to go on a TV show to get it fixed, something like that. All right. Well, anyway, that's it for now. All right, off you go.